Right, good evening, everyone, and welcome to CAWASA's Wednesday webinar 2021 series number 9. And we're looking at decentralized MABR wastewater treatment. Just before we go ahead, I'd like to, I doubt there are any colleagues from St. Vincent joining us, but I think we should spare thought and always send a little WhatsApp message to our colleagues in St. Vincent as they're going through this difficult period. But the good news is that they have been doing a very good job at restoring the supply. I think the general manager, Mr. Garth Saunders, was on a radio show this morning with the Prime Minister of St. Vincent and the Grenadines, and he did indicate that they were near 60% of production, and they were finding alternative sources in springs because some of their surface water systems were totally clogged with the ash. So they're doing some cleaning up, and they're making some good progress with a lot of assistance from the regional and international community. A lot of the sister utilities have sent either bulk water or bottled water for the people, particularly those in shelter. So that's going very well, and we want to encourage you to continue to support our colleagues in St. Vincent and Grenadines. So this afternoon, I would like to welcome a good friend of ours, Mr. Alex Herrera, who is, I think, at our 2019 Caribbean Water and Sewage Association conference, operators conference in St. Lucia. He was down there, and that's when I first met with him, and we have been in contact. So we are pleased to have him as our guest, and he will tell us more about the subject. So over to you, Alex. The show is yours.
Okay. Thank you, everybody, for giving me some value of time for today. I just gonna be pretty much going to the main topic today, and it's gonna be the decentralized and also the MABR wastewater treatment solutions that we have here at FLUENCE. And I want to deviate a little more for the commercial part and focus more into the technical and the many good reasons why we should be moving to decentralized systems and more efficient technologies in the next upcoming years. So again, my name is Alexander Herrera. I've been seeing so very familiar names in the group. To all of you, welcome, and let's proceed. I'm just gonna give you a small background about FLUENCE. FLUENCE is a company that is globally with our headquarters in New York. Everything that you see as an operating entity is basically as manufacturers, and we have factories, each one with a specific application, and also we have the referent regional office. And in this case, myself, I manage the Caribbean and Central America region, mainly from home. And I still miss the good times when I was traveling to the Caribbean. But at the same time, is due to the pandemic, is part of the new normal that we have to adapt. So in the different solutions that FLUENCE focus, we have the water treatment, desalinization, as you many know, wastewater, waste to energy, reuse, and also we try to emphasize in what we call the decentralized systems. So let me know probably at the end, or if you guys have any question, feel free to interrupt, because I know my English is a little broken English, so I beg your pardon for that. But just keep smiling and try to follow as the conversations goes on. So mainly, what we are FLUENCE focus, and see the future of the water is what we call the cycle of the water. And the cycle of the water, it will be pretty much from the reuse to the treat to the delivery. So try to make sure you guys as a public entities, as a government entities that manage the water, always trying to, close the cycle. One of the things that we are going to be probably approaching today is into the wastewater. and it will be kind of a shame if we are still seeing wastewater treatment plants, dumping the reuse to the body of water after the wastewater goes to mainly to the wastewater treatment facility. So it's kind of the perspective that we are looking for to move from that. And right now, with the future in new cities that are be expanding, the new rural areas, and all those developing countries where there is very limited or no water structure, it's very essential for us to put a very good attention on what we are going to be doing, or what we rethink about the water and the future of the water is going to be for us. Right now, when we are going to be focused, when we talk about the centralized approach, and it's the very conventional, everybody in the Caribbean, South America, Central America, is very much stuck into those big mentalities when you have a big wastewater treatment plant, a centralized wastewater treatment plant. And also you have an infrastructure that pretty much is going to be covering two-thirds of the total CapEx that is going to be exposed. But at the same time, all the distribution network that you are going to have. And when you put that also to the OpEx, you are going to realize that, how much we are going to invest into the pump stations, how much we are going to be investing into the maintenance, how much we are going to invest into the failures and leaks. So when we talk about all those centralized and conventional systems that pretty much apply to all of us here in the Caribbean, is because we need to move from that mentality. As many of you, especially in the infrastructure, realize that sometimes there is not that the different islands doesn't have enough water production or enough water treatment plants. It's pretty much, they sometimes, and as many islands, they probably have enough to produce and supply to the whole community. But unfortunately, we have too much losing into that infrastructure, like at the oil piping, all the infrastructure, all those decentralized, and all that kind of equipment that unfortunately is making us lose probably. In some of the cases, when I've seen in the Caribbean, it can run up to probably 40% of what is the total production. So I don't want to mention the name of the islands, but I've been seeing in cases where probably the production of the water is being lost through the leakage, and we can count that production probably will supply the whole island. But at this moment, they are in need to start getting biddings for new projects, for new desal plants. But in reality, it's because the infrastructure is being deployed and needs to be some rehabilitation over there. And it's a topic that we can probably talk in some other day. So right now, when we start thinking about the different countries, without the existing of the infrastructure, and when we put all these in numbers, we got to the cruel reality that 40% of our pretty much communities worldwide doesn't have any access to drinking water. And it's getting worse when we talk about wastewater, sanitation safe. So the reason is when we decide, as FLUENCE, not only FLUENCE, I'm gonna say that, but I'm gonna say most of the companies right now are moving to decentralized systems, where each community is going to be responsible for their own wastewater and for their own water treatment plant. That is helping to ease the CapEx. It's going to actually help them to eliminate all the costs on piping, pump networks, large pipes. And when you have all those decentralized systems, it's very convenient in the way that you have attached, you can communicate all those networks. Remember, we are in an era with technology, and many of you are in very much different places. Most of you are in different places, and look at us, we are communicating. The same type have to be applied to all those decentralized, where we have a distribution network that is communicated. And when we pass that to the OPEX of the efficiency of the plants, it's probably, you can reduce the energy costs, you can reduce pumping rates. In the operation of the plants, once you have a network, is pretty much you have a team that can probably help, or if you have the same communities doing the maintenance, it's up to you just to be vigilant, and that's communities are on top of their wastewater treatment infrastructure or the water treatment infrastructure. So that will be in the operations. And the best part when you have different kind of standardized units or standardized decentralized approach is because the maintenance is going to be easy, because it's pretty much you don't have all those 1,000 different parts for pumps, pipe in different size of pipe, or different types of PLC. You just basically have one common that is going to be served all the distribution network. And when you compare the two, pretty much the two systems, when you have the centralized and when you have the decentralized, in reality, the decentralized, if we are going to put it by the number, you can reduce probably 1/3 of the capex that you are going to be investing, having a centralized or this big plan. Probably the last time that I saw a bid for a big plan is probably back in 2018. No, I'm sorry, probably way before that. And it was pretty much in Mexico. But in the Caribbean, if everybody start noticing it, everyone trying to be self-sustained in small communities, because that's the way to go to decentralize. You have more value, and at the same time, there is the value that you get involved the communities and you establish all those current needs. It's easy to upgrade those plans. So it's a fast delivery and installations. Remember right now, not only Fluence, but many other companies are doing, as we call, plug and play installations. Everything is by a container or a prefabricated unit. And the civil works are very limited to doing a slab or doing pillars where you are going to let the plant rest over there. And, everything is coming plug and play. You use inlet, your outlet, how you are going to treat your sludge, things like that, because everything is already prefabricated. So in the different scenarios that we have, we try to focus into the containerized package systems, because it allows you to be modular, allows you to be more creative, and at the same time are easy to deploy. While you do mainly of the civil works, you can pretty much build the plan. So your time is being diminished. Just to give you an example, a plant that we built in Cyprus, in this island in the Mediterranean, is 55,000 cubic meters per day. From A to C, I'm talking from the moment that the engineering starts into the moment that we are going to be commissioning the plant. It took an average, it took 8 months because we were doing everything together. So when we're going for the decentralized solution is because we're trying to be more cost efficient, we're trying to be faster, we have to be independent, and the most important part is that everybody trying to be sustainable. And sustainable is when you give ownership to the small communities to be on their own, to be self-sustained. So that's it create that kind of an ownership from them to replicate and take a good management of the plants or the equipment that is being handled to them. I'm back again to what the future of the water, the wastewater right now for us at the different companies is when we talk about the CapEx. Right now, every single company is focusing the reduction of the CapEx, and that's pretty much try to diminish most of the civil works, whereas you can probably get the more approach. And also energy costs. Remember, we have to move from those old good conventionals, very humble process, to process that have to be more efficient. When you have a wastewater treatment plant where 70% of your bill is the energy cost, you have to look for different options. Not only that, but look at the different regulations that are being applied in the different countries, in the Caribbean, in the US, where we are moving from just not only look at BOD, COD, total suspended solids, conventional TAs, dissolved oxygen, but also we are looking more in the toxicity of the water, nutrients. So right now is more into the total nitrogen that is being removed by the plant, the total phosphorus. Then unfortunately, if we go by the conventional process, you know, that is not feasible up to some point. And if you want to do the upgrade of the plant, it's pretty much you have to do another additional tank, or you have to do a different components to allow you to reach that goal. For example, here in the US, due to the new regulations, as everybody knows, is the Title 22. Title 22, where total phosphorus has to be below 5 and total nitrogen below 8. So in that case, we have here in the US close to 2 million wastewater treatment plants that needs to be retrofit to comply all those regulations. States right now here in the US are like Texas, Maryland, many other states that are being more stringent with those regulations. And when you look at the maintenance, is very common, and I've been seeing it on a trend. No matter A, B, C, or company, everybody is trying to do the remote connectivity. Then I will suggest to you guys, it will be shame if you guys trying to invest in new plants or anything, and there is not that remote connectivity. We should move away from filling out the forms. Right now, everybody, you know, if you see the employees, you know, get into WhatsApp, pretty much give them the choice, the tools. If they want to get it, you know, if they have a smartphone, they can easily fill out the forms while they do the different activities from maintenance for the plants. We are moving from the paper and having all those piles of information to everybody's having it on the cloud. Right now, most of the plants that we build is pretty much not only for our own personal commitment, but also for liability reasons, and also to provide additional information. Is we as FLUENCE, we have most of the plants in remote monitoring. That means that we have access to getting the information, and at the same time, we imply to the customer, you know, kind of telling you, hey, guys, you have to collect the information, put it on the phone, put it on your tablet, by all means, but don't leave it on just on a piece of paper that is going to be handled later on. So right now, one of the processes that we are pretty much implying is the MABR. Many of you already heard is the membrane aerated biofilm reactor. But this is pretty much, we have to focus. One, it will be the retrofit, and also what we are saying is going to be more like the decentralized systems. But prior to, for those that doesn't have pretty clear the concept of the MABR, let me start with a brief differentiation between the membrane that we all know, very common in our market as MBR or MBBR. I'm sorry, MBR. So where the MBR is pretty much a direct filtration process. So you have a physical barrier where you have a membrane that is going to be doing the filtration. And in the other process that we are referring here to them, let me see with the point. membrane. So here, when we refer is to the biological process where we are going to have a biofilm over a membrane. Let me see. I know that it's hard sometimes for you, but this is what we refer to the membrane. I don't know if many of you see it, and this is the material. So here in this part is where we are going to be create that biofilm. And look at this, is pretty much like an envelope. It's going to be a large size where I'm going to explain later on how the process goes. But at the beginning, I just want to make clear that differentiation. When we refer to the MABR, it's a membrane where we are going to do a biological process. It's going to be an anaerobic field that is going to be constantly removing the contaminants from the water. The beauty is that we have this static element that is meant to last at least 20 years. So as being an static element is no maintenance or additional cleaning that needs to be taken in place. When we go to the, with the different process that we have pretty much over the past 70 years when we start treating the wastewater. So most of you are pretty much get used to the activated sludge by extended aeration, but also the lagoon systems, also the MBBRs and the SBRs, and those are very common processes that are biological process. So when we are going to compare what the MABR benefits or evolution on the wastewater, it's pretty much when we talk about the mechanical aerators. When we talk about the mechanical aerators, it's probably one of the first ones when we try to push the air or bring the water in contact to the air with the air to expedite what all the process, the biological process are meant to be. And also later on, we change to the coarse bubbles, and after we change to the fine bubbles, and finally we come with the MABR. The difference, as you can see, is the amount of energy that is being required to pretty much treat a cubic meter of each one of the process. If we go into the surface water, we are going to be doing 2 to 3 kilowatts per cubic meter treated.
No, looking at running.
So if we go into the MABR, it's a big, huge difference because we are talking probably less than a quarter of a kilowatt per cubic meter. I just want to make a clear differentiation in this one. When I'm talking about these numbers, I refer to the biological secondary process. So you still having your equalization pump, you start having your mechanical equipment for your conventional plants, for your oil grass traps, everything that is your pre-treatment. But these numbers will be referred to the secondary, when you are going to have your diffusers, where you are going to have your mechanical aerators, or so on. Pretty much over the years, when you look here, is pretty much what we are doing is blasting air through the water. And pretty much that will be, he will be kind of accounting at least of 50% of your energy cost when we are applying all that energy, but in reality, only probably 10 to 15% of the oxygen that is being delivered through the use of that energy is being utilized. And that's what we are gonna say is the oxygen transfer efficiency. So when I talk about the MABR, the first thing that I refer to the customers is, is imagine it's going to be a stationary valve and it's being submerged in your plant. So we are trying to go from that an efficiency system that is going to be only allows to use 10 to 15% of the oxygen trapped in that fine bubble that is going to be quickly run through the water. So as something that is more stationary and allows to use the total oxygen that is being delivered to the bubble. So the MABR also can refer to your lungs. And if you see the competitors, the other competitors very much, they are going to call it One of them is the C-long, because it's the same functionality. You have air. Don't put like the membrane is these little tiny holes, because there are not going to be holes or anything. It's pretty much that air that is in your lungs is going, what is need to go into your bloodstream is the oxygen. So it's gonna be called the past diffusion of the oxygen, where that is getting to your bloodstream. It's gonna be the same. If you look at the membrane, the MABR have the same functionality. So it is kind of trying to find better ways to oxygen transfer and find a more suitable solution. Not suitable, but more sustainable solution. So instead of having that bubble travel through that column in a matter of seconds, you have pretty much all this stationary bubble that is gonna be at the end dissolve what is sits on the liquid. So that is pretty much what we are gonna be doing with the MABR, or what this technology refers. Probably here is gonna be easy for you guys to understand, because here is the membrane. Ours is a flat sheet. This is for illustration. So where you have air. So here is our membrane. So inside the membrane you have air. So the air is pretty much a high concentration of here on that part of the biofilm. Is going to create a high concentration of oxygen. If we already start following the process, so pretty much here in the on what we have the membrane, is going to be a growth of the biological film. This is going to be our biological film that is going to be growing. So in the first stage, we are going to take the ammonia that is here, and it's going to meet with the high concentration of oxygen that is in this part. So for everybody that knows, that is going to be the nitrification process. When that ammonia is pretty much is going to be meeting with the high concentration of oxygen, and it's going to be creating the nitrates. Those nitrates are going to be taking the COD as our carbon source, and it's going to be pretty much creating our nitrification process. So here in the biofilm, you have the simultaneous nitrification and denitrification that allows you to save pretty much in your aeration basin what the energy will be utilized for the dissolve of the COD. That is very related to the BOD. So in this case, the remaining of the COD that is going to be minimal is going to be going to your aeration basin at the end of the process. All this is pretty much what we refer to 300 micron aerobic and anaerobic film. Then is you going to the wastewater treatment plant is what we are going to call a three-stage where you have your anoxic, your aerobic, and pretty much your recirculation of your rust back again to your anoxic chamber. So that is what we are going to do with the MABR. It's a more clear example. While the MABR, we are going to still the aeration for the final polishing. You still change your primary elements for the clarifier and your secondary elements for the clarifier. So primary elements is still the same. And the beauty is that instead of having different chambers, you are going to have your only chamber, and it's going to be allow you to do the nitrification and denitrification at the same time. And at the end, your aeration is going to be allows you to reduce the final BOD that it wasn't dissolved by this MABR zone. So going and explaining a little more about the membrane. The membrane is pretty much full. That is being, it gives you a lot of area. When you compare with the MBBR, the beauty is that the beauty of those MBBR as well is because that allows you to have an area where you are going to grow a biofilm. Here we have a very long area. It's probably each 2-3 meters diameter is actually 25 meters long by 3 meters wide. That is gonna give you all this area to create that biofilm. And remember, this is a 300 microns biofilm. So through the years, this is a process that started many years ago, probably back in 2005. So they start realizing that too much biofilm, the thickness, it will affect how your nitrification and denitrification it will work. So as too much biofilm, you are gonna have too much scaling, and pretty much your denitrification processes start diminishing, because when you go back to the, let me go back to one slide. When you start increasing this, denitrification is gonna be start diminishing in your biofilm. So that is when FLUENCE comes with a solution, then it's better to create a biofilm, a self-breathing membrane with a thin film that allows you to create the best options into the denitrification and nitrification. And that's with several years of try and errors to get to the best specifications that we can allow. So as I showed you before, you have the membrane that is this roll, and this roll you have the first layer that is going to be the membrane outside. Inside you have the air that is going to be pretty much going through, just like a bubble over there. And you have your spacer in between two layers of the same membrane. And at the end, you have this black sheet that is pretty much the spacer. The spacer allows us also to grow the biofilm, and allows you to get the benefits when you have a good mixing liquid in the process. So what are the benefits of the MABR process? Besides, it's going to allow you to diminish many of the nutrients that we are looking to treat right now. And when I'm talking about the nutrients, I'm talking especially about the total nitrogen. With the MABR, we have cases that pretty much all along the different plants, our common denominator is to get results probably 5 below in total nitrogen. The total phosphorus, we can say we remove almost 90%, and that is because of the biological process. It's something that pretty much came along to the try and error, because we never look for trying to remove the phosphorus at the beginning, but through the different frustrations, we realize that biofilm also, depending on the thickness, it will allow you, and also in the stage, allow you to do a better gradient removal of the phosphorus. Second most important benefit that I will say is the energy savings. When I have to compare is pretty much if you have a 200 horsepower blower, you are not going to be needing that 200 horsepower blower. You are going to be needing probably a 20 horsepower blower. Then it's going to be doing the same function, but at this moment it's going to be less energy required, because most of the process is being done by the eutrophic and anaerophic bacteria into the nitrification and denitrification. So also the small footprint that we allow is great, because here I have to do the differentiation with the MABR and the MBR, because in reality with the MBR, and everybody knows, you can diminish the sizes of the plant. But when we do the MABR, we also reduce the size, but not in the same gradient that is going to be reduced by the MBR. But remember, with the MBR, you very much have another elements that you're going to be sacrificing, because you are going to be consuming more energy in order to save more space. And the quality from both are kind of very similar, without the high energy element consumption that is being done. One of the things, FLUENCE, pretty much all the manufacturers of, at this moment, there are only 3 pretty much putting the MABR process out in the market. And in the membrane as being a static element, very durable. The warranties, like I told you, is meant to last 20 years. But at this moment, Fluence is giving a warranty of 15 years. But we know that the life expectancy will be much greater. One of the things, and also, is you are going to reduce your chemical consumptions because you are not going to need to add any carbon or aluminum if you need it in some cases. The maintenance is going to be very low. When it's a greenfield plant, pretty much a new plant, is because the blowers or the other elements are not going to be in this high power range. It's going to be probably a small horsepower that it's going to be utilizing. And when we spoke about the odor control, it's going to be one of those elements that doesn't produce any odor. Excuse me, it will be one of those items that I will say. So far, based on our experience in all the plants that we have developed worldwide, we don't have any odor experience. And everything that we are saying, we can pretty much drive you by the different results that we can give to, that we are being obtained as doing the remote monitoring of the plants. So right now, going to the different process of the plants, this will be the configurations that affluence we have. We have the micro that is for a small kind of household, farther away communities. We have the spiral that is going to be the package, hotels, condominiums on a larger site. We have the spiral plants, the sub-remodels, and we have the pretty much the upgrades, Subre Greenfield, Subre Retrofit, or Subre Greenfield, and it's going to be the upgrades for the plants. So this is the pretty much the different capacities that we are trying to go with the Aspiral, the containerized units, and it will be from 20 to 50 to 5,000 cubic meters per day. Greater than that, it will be feasible. Unfortunately, it will be too much horizontal construction. And sometimes in the Caribbean, we know that the land has some value. So if we can go and move to different capacities, for example, when it's a 2,000, move to a Subra, when we can do a vertical construction, so a deeper tank, it will allow us to do more efficient and more much smaller process. I have a case right now, for example, in Panama, and we are changing it's a 14,000 cubic meters per day wastewater treatment plant by oxidation dish. And the reduction of the area is 2/3 of the oxidation dish. And in this case, we have 4 channels, try to mimic what it was over there as the 4 trains of process. So it's a very good reduction when you can kind of do, deeper tanks, because the Subre models will allow you to do that. So these are the spirals. As I mentioned, we have the small one 20-foot container can be 50 cubic meters per day. The 40-foot containers, a spiral M is pretty much everything coming used in the plant, where you have your clarifier, you have your aeration, you have your recirculation. The only thing that you will not have, it will be your equalization tank. And you have the spirals L, and it's pretty much when you want to build your secondary clarifier, and you just want to increase the capability of the reactors, you don't need to buy the units with the clarifier inside. You just pretty much go and buy the units, and you just build your clarifier, keeping in mind that your pre-treatment is still doing the same. So this is pretty much because we want to accelerate those decentralized systems where it is minimal infrastructure and pretty much everything in the spiral plants is plug and play. So everything is, ready to put it into the plant and ready to pretty much roll it on. Even the control panels and the instrumentation, please don't forget that at some point you have to bring the electrical power from the plant and also to the mechanical equipment, like at the blowers mainly, because those are usually being put outside of the plant. Pretty much is what I refer principle initially is when you want to retrofit some plants or when you have new, but you have deeper tanks. In that, yes, we can reduce the cost, we can enhance the nitrogen removal, and also when you want to increase the flow of the a facility, it will be pretty much, we can help you with that. But also keep in mind that when you want to increase the flow, you also are going to have to increase at some point the junction box or probably the pumps that are going to be feeding the plant. Because not only, I can tell you, yes, it will be increase the flow, but the pretreatment has to be increased in order for you to build all that flow with the same infrastructure. This is what we see as a conventional activated sludge, where you are going to have your typical installation, you have your membranes, and pretty much you diminish all this space than it will be the conventional plant to a more efficient and more durable, with up to 20% reduction of the OPEX, 30% of reduction of the energy consumption. It's going to give you a more suitable effluent quality, because the quality that we are getting right now, for example, in some of the cases, is the conventional BOD TSS 2020, but when it's coming to total nitrogen, we are places we are like below 5. And it's very convenient because we don't have to add all that conventional infrastructure, like add another mixer or another anoxic tank. It's very common use for us in the past. So, and when it's coming to the operator part, is I said to them, this is a static element that you are putting into your plant. So it's the same operation that you have been doing on blowers, is the same operation that you have been doing in diffusers, the same operation that you have been doing in pumps when you compare with conventional process. This is the membrane. The other thing is have your inlet, your outlets, and those are membranes that are pretty much to make you last for at least 15, 20 years. So if something happened into those cases, I will say FLUENCE have FLUENCE, pretty much all the companies, it will be replaced, no question asked, because we will do all that autopsy of the plant to see what's wrong with the plant. But that will be similar as you guys are doing in the Arrow for all those that work with the Arrow system, replace it after we do the autopsy on the plant. So, and this is the different configurations that you can see on a super plant in case that you want to start diminish all your space and you want to lower as much super or MABR elements you have in the plant. Keep in mind that your energy cost will be probably getting lower and lower by the time. So here are some of the results that we are being obtaining from when it's coming to treat the COD in the different stages. Compared with the conventional gas, is more likely that we have more removal, but with the less energy consumption. Remember, in the initial one of the main slides, I was showing you how the process works when we take the COD as a carbon source with the nitrates for the denitrification. So in the same thing is here, the COD that is getting to your final clarifier is going to be minimal. When we are talking about the ammonia and the nitrates, it will be the same stage. You are going to see that more and more reduction as you advance in the stage. The total phosphorus at the beginning, you are going to be kind of getting not as such efficient, but as much as you go into the stages and in your plant, you are going to get more and more efficient reduction of the phosphorus. Finally, this is a pre-comparison between the different technologies. When you have the conventional T-Brex flush, the MABR, the MBR, everyone has their goods and their bads, and this will allow you to let you know what it will be the good. For example, if we are going to compare all of these technologies with the effluent quality, there is no doubt about it than the MBR. It will give you an outstanding quality, but the MABR, it will be higher, better than the conventional, while the energy consumption is going to be less. And the total nitrogen, for example, removal, in these cases are going to be very high. But when you compare with the MPBR, the energy consumption is not going to be as great as we have it with the MABR. So this will be a comparison between why the MBR wins against the other. This is pretty much by the numbers. And not only by FLUENCE, but by the different entities, we are getting validated this technology by different entities. So most probably common right now for you guys, it will be Stanford Engineering, the Stanford University here, Black and Beach, we already being validated. Bacenta is another institution of wastewater treatments in Spain. So I remember as it happened in Jamaica, it was a process almost of 2 years for to get validated the technology, but it's being implemented. And as it's been implemented in one particular Caribbean island, I believe it couldn't be implemented because the benefits are greater. So all that takes us to pretty much a summary of what FLUENCE is doing into the environmental and sustainability impact due to the different projects and how we are participating. That is good for you as well, how to participate in, try to commit to all those 17 goals, where FLUENCE at this moment is pretty much committed, allow you to pretty much do 10 of the 17 goals based on what we are approaching right now. So this will be in the sustainability, the 17 goals. For me, the most important is that we are actually participating in the clean water and sanitation, and also with the affordable and renewable energies, and as well, is sustainable option for the different cities that our communities are being on right now, getting into the new phase to be self-sustained. So by the numbers, pretty much the annual savings on energy than FLUENCE is being approached is close to 23 gigabytes only by the MABR, and also the needle box. That is a desalination plant where FLUENCE has at this moment the most efficient plant in a single container when it's energy use. Through the different other projects like a waste to energy, how much we are saving on the carbon, the annual impacts that FLUENCE produce. So this will be pretty much coming to an end. Those are the different case studies, and you guys probably, I invite you to see on the webpage from FLUENCE. And also, I probably invite you to as well visit not only FLUENCE, but the different entities that you guys are being approached with new technologies to start getting more approach and more knowledge in that. Also, at the same time, I will say, it's good for you. Look at this, it's not only FLUENCE, but also many other companies are having the same approach, where when you visit, it gives you help on the design of the wastewater treatment plant, and also on the water treatment plant, pending of what you influent and effluent requirements are. And at the same time, another tool, and it will be good for you, and is being utilized in many other companies, is, when you have to compare your current plant to what it will be my energy calculators. Because remember, on the wastewater, at this moment, the most important element is pretty much the energy, how you can reduce the energy and how you can improve your nutrient removals pretty much for the plant. So continuing to the same, I believe so, Ignatius. So if you guys have any questions, it will be right now the time. I don't want to emphasize too much into the different options, into the different projects. At this moment, it's only worldwide that we have 260 MABR plants installed when you compare with the millions of the different processes. So it's a new process, like the MBR back into the 80s when nobody has too much trust in that. But you look at now, there are 1,000 of those MBR installations worldwide. So it's the same approach and the same slow movement. So we have to see, I start to embrace it, the new technologies, and try to apply it, because there is a lot of benefit. I'm telling you, not only from my side, but it's from also from all the participants that are being working on this process in this new technology. So with that, I let you take back, Mr. Ignatius.
Yes, thank you, Alex. That was a very comprehensive presentation on some of your new technologies, and I'd like to thank you immensely for that. We are going to take questions. If you have any questions, you could put them up in the chat room, or you could just unmute and put your questions together. We have a very quiet room this evening.
Yes. So this is good. So they didn't got my broken English.
There's a question in the chat. Do the unit have to be removed for cleaning, or is there a back washing system to remove excess biofilm?
You don't have to remove the unit once it's being installed. It's going to be a static element. What is in the bottom of the unit is a diffuser system, like a defined bubble diffusers. And every cycle is pretty much for 5 seconds, every 5 minutes, the scrabbling of the bubbles are gonna help to clean the biofilm on the membranes. So that's the way how we clean the membranes, or how we make sure there is the falling of the old biofilm into the chamber. So there is no taking it out. You take it out only because actually something wrong with the membrane, or because you see the on the well collection, you will see that there's too much water accumulated. There is, I forgot to mention it, there is a well collection, because sometimes you create condensated water inside of the biofilm, inside of the membranes. So to avoid that getting water all over, we have a system that is going to be pretty much like a well, wet well, that is being attached to the system.
Any other questions? Thank you with this one, Alex.
So, guys, also there is plenty of videos, self-explaining videos with a better English, I will say, in the web. Feel free to go. There is a lot of information to be downloaded. If you have a specific question, feel free to, give me a call, send me a WhatsApp message. whatever you guys feel more comfortable. More than happy to answer and, you know, get any questions on a personal basis if you guys need it. So here is my information if you guys need it. I know, feel free to shoot me a WhatsApp message. More than happy to answer any questions if you have a specific project. Doing the evaluation of the project, it doesn't hurt. It's not gonna be a charge or anything. But if you want us to evaluate, more than happy to do that. At the same time, it's gonna be kind of some information that we need to gather. And if you guys can help us, it will be much better. Okay.
If
Any
there are
further questions?
any other questions? We don't seem to have any others.
Yes.
Well, there have been none. That leaves for me,
Mhm.
Alex, to thank you very much and your team at FLUENCE for taking time off to share with us some of your knowledge and some of your systems and your packages. I'm
Mhm.
sure the operators here with us can always either contact you via your contact you sent and I can share with them, or they can always contact CAWASA for more information.
That's correct. Not only is it for the wastewater, also we have a lot of knowledgeable people, mainly in Israel and here in the US, regarding water desalinization. So any question that you guys have, more than happy. If I cannot give you the answer, pretty much, I know how to, one of our team will help you with the answer. And Ignacio, thank you so much. For all of you that are close to St. Vincent, our thoughts for everybody stay safe, healthy. Please, anything that you need, more than happy. We are here to help you.
Thank you very much. And this is Ignacio Ja, Executive Director of CAWASA, thanking you for joining our CAWASA webinar series 2021, number 9. Have a good evening. Signing off. See you next week. Bye.